Hi, I'm Matt, and I work together with the electrical sub-team.
Hi, I'm Sarush.
I'm Kai Rauk.
And we are part of the propulsion subsystem.
Hi, I'm Thomas Faring, and this is Nicholas Zarilli, and we're part of the steering sub-team.
Hello, my name is Jack, and I am in the electrical team.
Hi, I'm Christina. So, my electrifying personality has put me as the honorary member of Solar Racing's electrical team.
My name is Wesley. I'm part of Stony Brook Solar Racing. I'm the current electrical lead and vice president. So Stony Brook Solar Racing is a student-run organization that's been participating in Solar Splash since 1998, on and off. We're made up of 3 sub-teams: mechanical, electrical, and software, and we work together to build this boat every single year.
This is my first year as part of the Solar Racing team, and I really enjoy being here. I think one of the experiences that was really cool was just like when we were organizing stuff for the boat. I feel like I was going nuts as I was organizing the boats, but I also feel like the ripples that this wonderful organization has on the community around us is super awesome. Like here we sort of have a space where everybody just pulls around, laughs, jokes, and learn all about wires, motors, propellers, everything.
Oh! It's working! It's working! It's working!
Running Tiggy.
Yo! Yes! I recorded that!
Let's go.
Our team for the last 8 years has been using 2 Agni 95R motors. This year, we were finally able to afford a Peregrine 40 motor, which should prove to be much stronger than the last 2.
So our system that we designed uses a Peregrine P40 that runs at 48 volts DC, but we're currently running at 36 volts. This motor outputs 40 horsepower, and in order to transmit this power, we designed a coupler that connects the D shaft of the motor to a spline shaft from our lower unit. And this was the main challenge of our design.
The lower unit is from a 40 horsepower Mercury outboard, and we paired it with a Black Max propeller from Mercury. It has a 17-inch pitch and a 10-inch diameter.
Through the electrical team, I was able to gain hands-on activity, hands-on experience in soldering, working with connections, how the wires work, and essentially the introductions to everything. As unlike everyone else in the team, I am a science major who wouldn't know much about the electrical components of anything, but the senior members were very kind. They were very helpful, and they provided adequate training and adequate practices in order to allow me to gain the knowledge and experience to have a slight understanding of what's going on.
Okay, so for the steering conceptual design that we decided to go with, we wanted to be able to trim the outboard motor and also steer it from the console using a steering wheel. Last year they had, I believe, buttons for steering and linear actuators to move an inboard motor system. So we just kind of wanted to revamp that this year and work with the propulsion team to create a whole new propulsion system. And so for that
In order for us to achieve this design, we decided to go with a hydraulic steering system. So we installed a hydraulic pump into the steering console, connected to the steering wheel. We ran hydraulic lines through the length of the boat that went to the back of the boat, where the hydraulic cylinder was mounted on a bracket, which was connected to linear slides. These linear slides were bolted to the back of the boat, and we connected a linear actuator to this console and this bracket in order to raise it and lower it. So this was pretty effective because the steering system was very responsive, and the boat has a very nice real feel when the operator or the skipper is using it. And the linear actuator is good because it was able to raise and lower the motor system about 8 inches at max, which is good because it helps us get the boat in and out of the water, and it helps us achieve optimal prop depth, especially for some sort of races as the endurance race, where we're going to need to limit our power consumption and try to find the most efficient way to operate the boat.
So our system consists of a main frame, which is built out of 1.5 inch 80/20 aluminum extrusion, and then from there we use a VVOR hydraulic steering kit, which is a commercial kit you can buy, and all the commercial components that we use in our design were integrated onto the frame via custom bracketry, which was made in the Stony Brook machine shop.
Thank you for giving us the opportunity to compete in Solar Splash this year. We hope that we can make a bigger splash, and I bet we'll have a lot of fun doing it too.